Good morning. All right, good morning. Happy Monday. Good to see all of you. I hope you're hanging in there. Thank you for everyone who's letting me see you instead of talking to a blank screen. I appreciate that. Can you guys give me a thumbs up if you can see the boards okay? Okay, thank you. All right, I do have some announcements, but I'll wait for those after I start the lesson. You do have an exam today at 2:30. People were asking me, do we not come to class? You're always going to come to class on Monday and Thursday. And during class, I'm going to be teaching. So remember that I'm on this very strict schedule. I'm only meeting with you twice a week instead of 5. So I need to keep things moving or we're not going to get through some things that you're going to absolutely need. So I'm trying to get to the trigonometry, which is absolutely necessary for honors pre-cal. So today I'm going to teach lesson 16.2. It's solving exponential equations, and it's California Common Core Standard F-LE.4.2. In the Explore, they are going to have you solve by graphing, and that's by using a graphical approach with the calculator. I'll write one up on the board, but you're required to use the graphing calculator for this like we have done in the past. So for example, they want you to solve an exponential equation graphically. All right, someone has their microphone on, and if you do me a favor and just go to the bottom and turn your microphone off, that'll be great. You're welcome to use the microphone if you want to ask me something. Otherwise, if you can turn it off, that'd be great. All right, so in the Explore, which is also included in the assignment portion of your regular assignment, you're going to have something like this. So what you're going to do is you can simplify it if you want by dividing both sides by 275. You've seen me do that. In this particular problem, I'm just going to leave it. So under y sub 1 on the calculator, you would put 275e to the 0.06x exponent. Under y sub 2, you would put 1,000. And what you're going to do is you're going to use the intersect feature on the calculator. So you go to second calc, use the intersect feature, and you're going to come up with the ordered pair. Now, you're going to have to fix your window, because from 0 to 10 is not going to include 1,000. So you're going to have to go from 0 to 1,000 counting by 100s or something in your window, but you get 21.5164, comma 1,000. So what you're seeing is you're seeing an exponential growth function with a line. That right there is going to be your point of intersection. And so the solution to this problem would be the x value. So the solution, I'm not solving by hand, but with the graphing calculator, is about 21.5. If you have any questions about that or the graphing calculator, you can come to the workshop on Wednesday and ask me about it or ask someone else. But that's solving by using the graphing calculator. All right, what I'm more interested today then is solving exponential equations algebraically. And there's going to be 2 ways of solving this, and with all the examples that I do today, you're going to see me show the 2 ways. I do not care how you do it, but you have to pick one of the ways or use them, however you want. But let me write these up here. There's going to be 2 ways to solve algebraically. All right. The first way is to rewrite in logarithmic form using the definition of logarithms. So to rewrite in logarithmic form. So if you remember at the beginning of when we started talking about logarithms, I showed you the logarithmic form and its exponential form. That definition is what I'm talking about. And so you'll see me work those problems. The second way to do it is using the property of equality for logarithms. This property of equality, sometimes, I don't know why, they won't put it in a gold box. Lots of times in a lot of books, I don't remember in your book, they won't even call it the property of equality. So students don't really see it or know about it or even know the name of it, but I will show you it is an important property and it is a useful property. So I'll actually show it to you right now. What the property of equality says is that if you have log base b of x, and that's equivalent to log base b of y. So if you notice, see the bases of the logarithm is the same. So whether it be base 4 or base 10, as long as they're the same, the property says that this exists if and only if, that's a really strong statement, x equals y. So you may not see that in your book. You may not see it in another book, but I know about it. It is the property of equality for logarithms. And basically what this is saying is if you can equate two logarithms with the same base, you can drop off the log. That's pretty cool. So you can drop off the log and just say that x is equal to y. All right, so let's look at some examples. Hopefully you have this written down. I'll erase it. Once again, if you do not have my notes, you should be taking notes. Everything that I write on the board is useful for you. I'm not writing it up here for myself, so make sure that you're writing everything down if you need to. All right, now I am going to be working these problems two different ways. So I'm going to call the first way A1, and I'll call the second, I'm going to work the same exact problem, I'm going to call it A2. So here's A1. The board to dry off. Frustrating. Okay, let's try it again. Transfer the pins. All right, so the first problem is 10 equals 5e to the 4x. Okay, this is an exponential. The reason why it's an exponential equation is because the variable x is in the power. So just because you have an exponent doesn't mean it's an exponential equation. It has to have x in the power for it to be an exponential equation. So in this first method, what I'm going to do is I'm going to simplify it first. So divide both sides by 5. So you would have 2 is equal to e to the 4x. And now we're just stuck. So the question is, what should we do? We can write this, we can use the definition of the logarithm. So in other words, we can write a logarithm, and since we're dealing with e, I'm going to write a natural logarithm. So we can say that log base, what would the base be? It's the base of the exponent, right? So log base, actually, let's see here. What am I doing? Right, it'd be log base 2, log base e is the base of the exponent, right? Of 2 equals 4x. Now, a lot of people get confused about this because it's like, where did this thing come from? And it came from that definition that I gave you at the very beginning of the definition of a logarithm, writing it in exponential form. So what I did is I took exponential form and I wrote it as a logarithm. So now what do? Well, we can solve for x. And the way we're going to solve for x is divide by 4. So see how we used the logarithm to get him down from there. So you have log base e of 2 over 4 equals x. Okay, so that would be an exact answer. So if I ask for it, if you can't divide 2 and 4, that's inside the logarithm. So that would be an exact answer. And if they want the approximation, you would put it in the calculator. So if you put it in the calculator, I think you get about 0.173. Okay, I'm going to do the second way over here, and that's going to be A2, that's what I'm going to call it. So same problem, 10 equals 5e to the 4x. And I'm going to simplify it just the way I did before in the other one. Divide by 5. Divide by 5. Okay, now what I'm going to do is I'm going to take a natural log to both sides. Now, why am I doing that? So I'm going to get natural log of 2 is equal to natural log of e to the 4x. So the reason why I did that is because you see this log base e of e, I'm going to be able to get the power down. So let's say that this base wasn't e, let's say it was 7. I would take a log base 7 to both sides so that I get log base 7 of 7. So the log that you're taking to both sides depends on the base of the exponent. So if the base of the exponent is 15, you would take a log base 15 to both sides. So anyhow, let me show you what's happening here. So this log base e of e cancels and you get 4x. So that's how we're going to get them down in this problem. And then over here, you have your natural log of 2. And then when you solve for x, you would get natural log of 2 divided by 4. So once again, that would be your exact answer, and your approximation would be about 0.17. So is there an advantage of doing one over the other? Not really. It's all a matter of what you like. If you're confused, just keep your seatbelt on. I'm going to do some more problems, so hopefully you'll see what it is I'm doing. So 2 different ways. Depends on who you are, which way you like. So it's your choice. We're solving an exponential equation. Anybody want to ask me a question while I'm erasing?
Miss Birch?
Yeah.
If it wasn't ln of e and it was ln of 7 and you would divide both of them, would you put the number that you get on the calculator for the equation, or would you leave it ln 2 over ln 7?
Yeah, I'm going to answer that question hopefully in this problem, but if you leave it as the natural, if you leave it as an exact answer, that's when you saw the natural log of whatever it was divided by whatever. That was the exact answer. Using the calculator, remember that natural log is always log base e. So natural log, it's on the calculator. So you have a log key and a natural log key. But let me see if I can answer that question, okay, with another problem. So let's do another one. Let's call this one B1. So in B1, once again, you have an exponential equation because the variable is an exponent. Minus 4 equals 7. So we want to solve this, and like everything else, we're going to isolate the variable. So we're going to add 4, so we get 5 to the x equals 11. We've isolated it. Now, how do we get them down from there? So we want to get them down from there in this method 1 by using the definition of a logarithm. So how do you write exponential form and logarithmic form? This would be not natural log now. This is log base 5 of 11 equals x. So remember, the base of the logarithm is the base of the exponent of 11 equals x. Remember the definition? So once again, this is where students get confused because they don't know the definition. So this is the definition of logarithmic form and exponential form. So there you go. This would be an exact answer. Now, if we want to find an approximation, you can't put this in the logarithm. So on our regular calculators, there is no base 5. In the newer calculators, you can put in a base 5. But I want to show you the change of base because I don't know what they're going to let you use on the SAT. I don't know if they're going to let you use a graphing calculator or use a scientific calculator. So you would have to use the change of base. So remember this? This would be log base 10 of 11 divided by log base 10 of 5. And now you can use your calculator. So go ahead and do that. Put in log base 10 of 11 divided by log base 10 of 5 and see what you get. Is that what you got? Give me a thumbs up if that's what you got. Okay, cool. All right, let's do it the other way now. So this is B2. Let's write down the problem. 5 to the x minus 4 equals 7. We're going to do it the same way as far as isolating the variable. So if you isolate the variable, you get 5 to the x equals 11. So now, instead of writing it in logarithmic form, we're going to take a log base what to both sides? Now, in the last problem, you saw me take a natural log. I'm not taking a natural log now. What am I doing? What kind of log? Go ahead and answer. Open up your mic and tell me, what kind of log do you think I'm taking to both sides?
Log 5.
5.
Yep. Log base 5. Good. Exactly what we're doing. And the logarithm is the base of the exponent. Because what happens when you do that? He gets to come down, right? Remember, log base b of b to the x equals x. So this is what I was saying, that whatever the base of the exponent is, if the base of the exponent was a 12, you take log base 12 to both sides. If the base of the exponent was 1/2, you take log base 1/2 to both sides. Because what we're doing is we're creating log base b of b to the x, which is going to be x, and that's how we're going to get them down by using the inverse property. All right, so we're back to this. So that would be your exact answer. And then you would do the change of base. I'm not going to do it if that's okay. You would do the change of base just like this. Don't get this mixed up. This is log base 10 of 11 divided by log base 10 of 5. Sometimes people switch them. You won't get the answer that way. So be careful about what you're doing with the change of base. Any questions before I erase this? You guys, I don't know. This is a different color that I'm using. Can you see this color, or should I use a different color? So can I see a thumbs up if you can see the color? Okay, give me a thumbs down if you really can't see the color. Thumbs up if you can see the color. It's turquoise. Nope. Okay. What about this color? Can't see it at all. What about this one? Is that better? Is the pink better? Okay. I'll use the pink. I'll use the pink on this problem. So you'll see the pink. Take the logarithm both sides. All right, I'm going to stop for a minute. I'm hoping everyone who's late is here. Need to be on time to the lessons. All right. Today at 2:30, you're going to be taking exam 15-1, 15-2, and you must take it. If you do not take it, I need to have your parents contact me as soon as possible. So if I understand if there's an emergency or an extenuating circumstance, I get that, okay? But your parents have to contact me as soon as possible. You can't just miss the exam. So you must take it. Couple things, 16-1 is due tomorrow night at 9 o'clock. And if you noticed, I've already put lesson 16-2 on Google Classroom. It's due on Thursday at 9 o'clock. I did include the answers for practice AB this time. I was able to find them and include them. So there's 3 links in lesson 16-2, and one of those has practice AB with the answers. So I'm trying to give you as many answers as possible. I have given you the answers to 16, and I'm hoping that you're ready to take this test. All right. This weekend, I had a practice on Saturday, and you're not expected to meet with me on Saturday or Sunday. So let me make that perfectly clear. This is all voluntary. So you're not expected to meet with me, but I did record it. And the reason why I recorded it is because I'm going through online problems that look exactly like your exam. So it was very beneficial to people who showed up, because if you do those online problems and you do practice them, you're going to be very familiar about how to go through the exam, and it should be no issues. So I actually went through problems that I'm not going to put on the exam, and I went through the problems that I did put on the exam. So it was very valuable. If you have the opportunity, if you weren't available, I would watch it on YouTube. But it was very beneficial if you were around for that. One more thing, and then I'm going to continue on. I am not looking at the grades in Google Classroom, and I don't think you should either. All right, I haven't looked at them. I don't care about them. All I really care about is you putting in your assignment percentage. As far as the exam grades go today, I'm not putting them on Google Classroom automatically. I don't care. I'm not looking at that. I'm putting your grades on Zangle. All right, so I don't have 2 different classrooms going on. Okay, I'm using Google Classroom to make announcements in the stream. I'm using Google Classroom to give your assignments, to give the links, to accept your assignment percentages, to tell you about the exams. But as far as the grades in Google Classroom, I'm not looking at those grades. Okay, so I have not uploaded your grades to Zangle because we've done a couple of assignments. We haven't taken an exam. So I'm just letting you know, when I get the result of this exam, I will upload the grades to Zangle. So don't pay too much attention to the classroom exams, okay? Your grades are being uploaded to Zangle. All right, so there's been some concern about that, and don't look at the grades in classroom. You're paying attention to Zangle. And And like I said, the main goal of this classroom right now is to enhance your grade, number one. Number two, to get you prepared for honors pre-cal. So if you're wondering, you know, that it is an honors class. I am meeting with you only twice a week, but I'm giving assignments for 5 days a week. All right, so you have to stay on top of things. You have to be self-disciplined. All right, let's continue on. So next, another problem, we'll call it C1. The first method. This one is 2e, here we go, the natural log again, minus 1 plus 5. So it's getting more complicated. So once again, we do want to isolate the variable, and this is an exponential equation because the variable is an exponent. So we're going to subtract 5 from both sides. So this is 2e to the x minus 1 equals, what is that, 75? And then, unfortunately, we want to isolate, divide by 2. So this is e to the x minus 1 equals 75 halves. All right. So remember in this first method, we're going to write the exponential equation in logarithmic form. So we're going to use natural log because that's an e. So it's going to be natural log of 75 halves equals x minus 1. So once again, this is coming from the definition of a logarithm and going back and forth from exponential to logarithmic form. All right, so when you solve for x, you get x is equal to this thing plus 1. 1 to both sides. Okay, that is the exact answer. If you want to put this on the calculator, be cautious. Make sure you put this in parentheses, or it will only evaluate the natural log of 75. It'll do this. It'll evaluate the natural log of 75, and then it will divide by 2, and that's not what you want. So you have to be careful about how you put it in the calculator. So what I would do is I would put this in the calculator as natural log of the quantity 75 divided by 2, hit enter, and then add 1. So see what you get. It's about 4.6243. And hopefully they'll tell you how to round. Right now I'm just taking the number out. Nobody's telling me how to round, so I'm just writing it out. In C2, the same problem, 2e to the x minus 1 plus 5 equals 80. I'm going to isolate it the same way. 2e to the x minus 1 equals 75, divide by 2. Okay, now I'm going to use my pink marker, see how this goes. And what kind of a log are we going to take to both sides? We're going to take a log base e, which is natural log, right? So what you have here is the natural log, or log base e, of e to the x minus 1 equals the natural log of 75 halves. So log base e of e is going to bring that power down. Add 1 to both sides. So this is your exact answer. And then you can put the rest on the calculator by being careful. Anybody want to ask me any questions before I go on to the problem solving? We are going to work some of those. So the problem solving, anyone?
It doesn't matter which equation we use on the homework, right?
You mean which method?
Yeah.
It doesn't matter which method.
Okay.
Some people are going to like this. Some people are going to like that. It doesn't matter. I'm just showing you two different ways to do it. It's your choice. Any other questions before we go on? Okay, right now I'm having trouble seeing this board. Can you guys see it? Can you see the entire board? Yes. Oh. Okay, because I'm looking at my screen and I can't see the entire board. So as long as you can see it, that's all that matters. All right, just a reminder too that I am taking attendance by your assignments. So I've been instructed to turn in a list of names of people who are not attending, and the administration will be contacting those people. So just make sure that you're turning in assignments. I am taking attendance with the assignment. One other thing too, don't go into Google Docs and turn in the assignment that way. Please turn in the assignment from Classroom. People who are going into Google Docs, I'm getting two different assignments. I'm getting a blank assignment percentage and a percent. I don't want that. I just want the assignment percentage. That's all I want. So please put in your assignment percentage from Google Classroom. Click the link, put in the percentage. Don't do anything different. I don't want a lot of extra work and a lot of different papers. In addition, with the test today, don't forget to submit your scratch paper. Your scratch paper is critical to you getting the exam grade. If I don't get the scratch paper, you can't get the exam grade. So you must submit your, that's why I gave time. You have 50 minutes, 50, to take the exam. I gave extra time for you to submit your scratch paper. After 50 minutes, the test will, the program will lock you off. So you only have 50 minutes to take the exam starting at 8 o'clock. All right, if you look with me on page 802, I want to look at problem A. It's a banking problem. So example, it's explained to you on page 802. Suppose that $250 is deposited into an account that pays 4.5% compounded quarterly. In other words, when you deposit your money at the bank, they pay you interest. So in other words, if you want it a year later, if you try to take your money out, you're not going to be taking out $250. You're going to be taking out more for allowing the bank to borrow your money. That's what interest is. So you get interest on your money. The equation that gives the amount A in the account after n quarters for an initial investment P that earns an interest rate R. Solve for n and find out how long it will take for the account to contain at least $500. In other words, you're going to keep your money in there until it earns $500, and then you're going to take it out. So if you write this formula down, A equals P times 1 plus R over 4 to the n. Okay, let's talk about what all this means, these variables. Okay, first of all, P is the principal, and that's the money that you're putting in the bank. So you're putting $250 in the bank. Okay, what about R? R is the rate of how you're earning money on the money that you put in. So it's always a percent. Okay, we've talked about this before. So the rate in this problem is 4.5%, but we need to convert that to a decimal, which is not 0.45. You have to move it. Division by 100 means move the decimal twice, so it's 0.045. So don't mess that up. It's not 0.4. Percent means division by 100. You have to move it twice. Okay, and then A is the amount you're going to earn. And so you're wanting to make $500, right? And what you're interested in is this N, which is now in quarters, as explained in the problem. Now, a lot of times, N can be different things, but right now, they're defining it as quarters. So basically, the question is, how long will it take? And so we're solving for N. It is an exponential equation. So let's put the numbers in. So 500 is what we want. The principal is what we put in. And this is 1 plus the rate, which is 0.045 divided by 4 quarters, right? So you can see how they came up with this formula. So there's 4 quarters in a year. So we have N. All right. So probably at some point we're gonna have to use a calculator, but we don't want to put all this in the calculator. We're sure to mess it up. We want to simplify it. So I would divide by 250. If you divide by 250, you get 2 is equal to that stuff. Just write it. 1 plus 0.045 divided by 4 to the N. All right, so I'm still not going to put it in the calculator yet. I'm going to add this first. So I'm going to put that part in the calculator. So on your calculator, what is 0.045 divided by 4? Hit enter and add 1. So put this in the calculator first, and then hit enter and add 1. And don't round too much. Is that what you got? Can you give me a thumbs up, please? Yes? Okay, and this is to the N power. Okay, so now what? We're stuck. And we have to use one of the methods I taught. And so I'm going to take a log to both sides. We're going to solve it. I'm going to take a log, base that to both sides. Do I want to do that? No. It's too messy. So I don't want to take a log, base that to both sides. I'm going to change my mind. What do I want to do? I know. Can't we use, let's see here. Watch what I'm going to do. I'm not going to take a log base that. That's too messy, but watch what I'm going to do. I'm going to take a log base 10. Watch what's going to happen here. So if you're wondering, okay, why is she using log base 10? That's not going to get her out of this mess. And you're right. Can I use the power property? So I'm not going to be able to cancel anything the way I did this, but can I use the power property and bring the N down in front? So if I have log base 10 of 2 and I use the power property and bring that down in front, can I solve for N now? So can I divide both sides by that mess? Log base 10 of 1.01125. Look at that. So N is equal to this. Now, these are both base 10 logarithms, so we can put it in the calculator. So why don't you try it? Put in log base 10 of 2 and divide by log base 10 of 1.01125. Just going to put the N on the left. So did you guys get about 61.5 0.96. Yes? Okay, so it will take about 61.96 quarters. And if you convert it, that doesn't make any sense to anybody. If you converted it to years, it would be about 15.5 years for the account to contain at least $500. So if you want to talk to me about this conversion, we can do that later, but it's going to take about 15.5 years for the account to contain at least $500. This may not, remember, this is in quarters, may not make sense to people. I'm going to work one more example. Is it okay if I erase this? Looks horrible, but not that bad. So here, I could have used log base 1.00, but I didn't. I used it to get him down using the power property. On Wednesday in the workshop, if any of you missed my review on Saturday and you want me to show you how to get the online problems that look like the exams, just let me know. Nobody's been coming to the workshop, so that means either everyone's lost or everyone knows what's going on. All right, let's look at this next problem on page 803. Example 6. It's under your turn. So it says, how long will it take to triple a $250 investment in an account that pays 4.5% compounded quarterly? So in this problem, we would use the same formula. One plus r over 4 to the n. Quarterly again. I'm going to write down my variables. So let's do p first. What are you putting into the account? $250 again. And then our A, we want to triple that, right? So don't we want 3 times 250? And the rate, once again, is 4.5%, which is 0.045. And once again, they want to know how long, which means we're solving for n. It is an exponential equation. So now we have 3 times 250, which is, I think, 750, is equal to the principal times 1 plus 0.045 divided by 4 to the n. I would simplify. So if you divide by 100, you get rid of those zeros. And now divide both sides by 25 would be 3. Is equal to 1 plus 0.045 over 4 to the n. All right. So I would add this again. Careful what you're doing. We already know what this is, right? We did it. It's the same as what we had before. And that was 1.01125 to the n. Okay, so how do we get him down? We could do it the same way. We could just take any log. But I'm going to use log base 10. Sorry. because I'm going to use the power property to get him down this time. So log base 10 of 3, log base 10 of 1.01125 to the n. And now I'm going to use the power property. So bring him down in front. Log base 10 of 1.01125. Solve for m by dividing both sides by log base 10 of 1.01125. Log base 10 of 1.01125. That cancels. And go ahead and put that in your calculator and see what you get. It's log base 10. See, so you can use, in this pink, you can use any log, but we don't want to use log base 3 or log base 2 or log base 5 because we want to use our calculator. So we really do want log base 10 or natural log. But we want to do something we can put in the calculator. So log base 10 of 3 divided by log base 10 of that thing is going to be about, did you guys get 98.2? Yes? Okay, great. So it will take about 98.2 quarters or about 24 years, 24.6 years to triple a 250 discount. So I don't know if investment, I don't know if you want to do that. So I'm going to read this again. It will take 98.2 quarters or about 24.6 years. It's about 25 years. Crazy, huh? 25 years to triple an account with an investment of 250 at that rate. Not good. So I don't know if you want to wait 25 years to triple that amount. Okay, in this assignment, that is the lesson, and I'm going to turn off the recorder in a minute. You're going to do 1 through 20 all, but you're not going to do 14, 15, and 16. So there's a few applications I want you to do. 14, 15, and 16 you will not do. And I have that in Google Classroom. So I also provided some extra problems. If you do the assignment, you should be good to go for this lesson, which is 16.2. So Wednesday, I hope you take advantage of the workshop. You will be taking a test on 16.1, 16.2 in the very near future. I was going to put them together, but I decided to create 2 different exams. So just don't forget your exam today at 2:30, 15.1, 15.2. And now that I'm finished with 16.1, 16.2, you will be taking an exam on that in the very near future. All right, I'm going to turn off the recorder and then I'll take questions. Let me just do this real quick.